Hello everyone. Today we will be discussing kinematics. Now, what is kinematics? Why do we study kinematics? Kinematics is basically one of the most basic chapter of physics, which deals with motion. Suppose we push an object, and the object will move. Now, push the force that is given on the object is the reason the object will move. That is part of dynamics, the application of force. In kinematics, we'll talk about just the result, which is movement of the object, velocity, displacement, acceleration, this kind of things. So first of all, we have to define the movement, define the motion. We live on Earth. Now Earth rotates around Sun, Sun rotates around our galaxy. So everything is rotating. There is no absolute rest. But as we are living on the Sun, living on Earth, we will take Earth as a frame of reference. Earth is universal frame of reference for us. And then compared to Earth, if object is moving, then we'll call it at motion. If the object is at rest compared to Earth, then the object will be at rest. So like if you are sending something, a probe to moon, then we'll calculate the velocity of the moon compared to Earth, and we'll assume the moon will be in t time will be at a certain position, and we'll throw the probe there or rocket there. So the rocket will come to moon's gravitational attraction, and moon will it will go to the moon. Moon will attract it due to gravity. Similarly, we are sending things to Mars, then we'll calculate where Mars will be compared to Earth, and then we'll throw the object rocket in that direction, so that that rocket can go into moon or Mars's orbital. Mars's, or it can go into proper position, so it will come inside gravitation pull of Mars, and so the object rocket can land on Mars. So this is how scientists calculate how the path of the trajectory of the object or rockets, right? And same if you are throwing a missile, you won't throw the missile. You are throwing a missile in a plane, so you throw not where the plane is, but you calculate where the plane is going, and you throw the missile there. That military tacticians, that right nowadays it can be just directly done by software. It's a control system problem, but you also can use basic physics and solve this kind of problems. So that's what physicists do basically, and you can use kinematics in your own life as well. You can just imagine you are going from A place to B place, and you have 10 minutes. You have to go there, so it's 1 kilometer. So you can just quickly calculate. If you have to go 1 kilometer, then in 10 minutes, then that means you have to walk in 6 kilometers per hour, right? Then you reach 1 kilometer in 10 minutes. So like this, we can calculate 6 kilometers in 1 hour. That means in 10 minutes, 1 by 6 minutes, 1 kilometer. This is easy calculation, but even for difficult calculation, we can use kinematics. If a train traveling 100 kilometers, and if train is going 20 kilometers an hour, then how long it will take the train to reach 100 kilometers? 5 hours. A train is going 1000 kilometers, and train traveling at 50 kilometers an hour, then how long it will take to reach the train? 1000 kilometers, 15 to 20 is 1000. 20 hours. So like this, we can use kinematics on our everyday. Now, as we are talking about motion, rest and motion, so from which frame we are seeing the whole phenomena, that is reference frame. We take a frame of reference. Like if I am seeing something, and if I am standing, suppose I am sitting on a train and train is moving, then from the train I will see the trees and houses that is moving backward. So my frame of reference is going forward. That's why I will see the trees and houses backward, and if someone is standing on the platform, they will see me going forward. So compared to that person, I'm at motion, and compared to me, that person is also at motion and train in opposite direction of the train, right? So that is frame of reference basically. Suppose there is two persons sitting on the plane. One person is walking. Let's say this person is coming here 5 meter per second. This train is going 10 meter per second. Okay. This person is moving 2 meter per second in the right, and this person 0 meter per second. He compared to ground frame, all the velocities are given compared to ground frame. Only this person is moving inside the train 5 meter per second, right? So for these two, the second person, this person will be going this direction in 10 meter per second. This person will be going in this direction. He is going 2 meter per second. There is 10 meter per second. So 8 meter per second. This person will go in the backward direction, and this one person will come towards him in 5 meter per second. That is, if we take the frame of reference of 2. But if you take frame of reference of 3, then this person is going this direction in, he is going 5 meter per second. Train is coming here 10 meter per second. So he actually will be going, the train will come 10 meter per second, but he will go 5 meter per second. So he actually go, compared to this person, this side 5 meter per second. Okay. This person will be going, this 2 person will be going, compared to 3 person, 10 meter per second. And this 4 person will be coming towards 3 person in 2 meter per second. So this is how, if we change the frame of reference, people's velocity compared to different frame of reference will be different. This people's velocity compared to him, he will be like, the train is going 10 meter per second, he is going inside the 5 meter per second. So he is actually going, if he was still, he would be actually going 5 meter per second that way. But he is also moving 2 meter per second. So compared to him, he will be moving 3 meter per second that way. This is how we'll calculate the relative velocity compared to one particular person. Their velocity will add relative velocity. How do you calculate actually? Velocity of, suppose, A compared to B will be velocity of A compared to ground frame or third frame minus velocity of B compared to ground frame or third frame, something like that. Okay, so this is how we'll mainly calculate the velocity. Frame of reference problems will solve like this. Okay, now velocity, acceleration, we'll discuss that. First let's talk about distance. Suppose first we have to assign a position. This person is in this position. Now we live in 3D world, so x, y, z, and in t1 time the person is in position 1, x, y, z position. Okay, in t2 time the person went x2, y2, z2. Okay, so let's say the person went this path. Okay, now this path, the total length of the path that the person covered, we'll call that distance covered by the person. Okay, and if we take a straight line between this r1 and r2, that will be displacement. So mainly displacement, we can write r1 position as xi plus yj plus zk. This is how we write position vectors. So x1i plus y1j plus z1k. R2 is x2i plus y2j plus z2k. Okay, this is how we write position vector. Then the displacement will write displacement between position r1 and r2 is, we can write it as del r. Del is an operator. Del means change in r. Del, the definition of del will be mainly change, like del x, del y, anything will be x2 minus x1 or y2 like del r is the displacement vector. Now del r, what is del r? Del of any function, del fx will be f2x minus f1x, means final of x minus initial of x, or any function like del v equal to v final minus v initial, del u equal del a anything, del f equal to final f minus initial f. So final position minus initial position, that is displacement, del r. Del means change, change means final minus initial, that's it in physics. Okay, del vector will add is this del, we'll use this del operator. Even in error we write del, and different places will use del. It's a mathematical operator, very easy to use. So to figure out difference, we have to write difference like dx by dt, dy by dt, we do this derivative. So dx dt, when that d is very small difference, okay, and del could be large difference, like 5 minus 3, that could, we can write it as del. But when we are doing dx by dt, then the difference will be like 0.00001 minus 0.000000001, like this kind of difference, very small difference that will measure with dx dt, small d, and this is del, this is larger difference. Okay, so yes, del r, this displacement is x2 minus x1i plus y2 minus y1j plus z2 minus z1. Okay, this vector is the displacement vector, and distance vector, displacement vector we also write as del s. It's a vector, it will be calculated in meter, displacement we calculate in meter, and speed and distance is the total distance. Okay, we can write it as del x or x, the total path covered by the object, x we can write it as, so del x by del t. This is the speed and velocity. Now again, as distance and displacement we explained, suppose object went 10 kilometer, and this straight line, if you draw straight line, then the straight line is 8 kilometer. So distance is what? Distance is the 10 kilometer actual path that object went. Displacement is shortest possible distance between 2 points, 8 kilometer. Okay, distance have only magnitude, no direction. Displacement have magnitude and direction both. All right, now velocity and distance is greater than equal to displacement, distance either more or equal to displacement. Okay, velocity two kind, average velocity and instantaneous velocity. Average velocity of the object is total displacement of the object minus total time taken for the displacement. Okay, that is del s by del t, total displacement by total time. Instantaneous velocity, when at a particular moment what is the velocity of the object, that will be instantaneous velocity. So del s by del t at del t tends to 0, so ds by dt. Okay, if there is a function, any function, if del s is any function, let's say at square plus bt, at square I plus btj. Okay, then figure out v, velocity, instantaneous velocity. So how will you figure out? ds by dt, it will be a into 2t I plus b, derivative of bt is b, bj. This is velocity. Okay, this is how we'll figure out velocity. And magnitude, if you want magnitude of the velocity, then it will be, what is the magnitude of this velocity? That will be 2a root under 2at square plus b square. Velocity at 2 second, velocity of 5 second, whatever, you put the value of t and you will get velocity at particular second. Okay, similarly we'll talk about average speed and instantaneous speed. Average speed will be total distance by time, instantaneous speed will be when del t tends to 0 at particular time, the speed of the object, that will be instantaneous speed. Okay, same as velocity. Now if we draw, like let's say we draw this graph, x is distance upward, t is going this way, so a b c 3 point, where is the velocity, where is the speed of the object is highest? Now speed of the object here, speed of the object, if you draw a tangent here at A, then theta, this tan theta is dx by dt. This you will learn in straight line. Similarly, dx by dt here, dx by dt here will be slope of this graph, slope of this line, slope of this line. Now slope of this line is higher at C, so velocity, this instantaneous speed here will be highest, then instantaneous speed here, then instantaneous speed here. Alright, so instantaneous dx by dt C, that is highest, then dxb by dt C, then dxa. So speed highest in C. Now speed, if object is moving in particular one direction, then speed and velocity of the object will be same. Object is not changing direction, okay? But if object is changing direction, then speed and velocity could be different. Alright, so in one directional motion, 1D motion will have, motion could be 1D, 2D, 3D. Like if I throw this object here, this is a 3D, this is a 2D motion, okay? This we need xy both coordinate to figure out this motion. But if object is moving like this is a 1D motion. It actually, you can say this is y, this is x, so this is a 2D motion. But we can just assume a axis in this direction, and then we'll get one-dimensional motion. So this motion is one-dimensional motion. We'll calculate. How do you find out what kind of motion? One-dimensional, two-dimensional, three-dimensional. We'll just take the least amount of coordinate system to explain the motion, and we can just take x-axis in this direction, and that means this is a one-directional motion, right? So this is how we can change the coordinate system to figure out what kind of motion it is. Now this motion will be two-directional motion. If also moving on z, then it will be three-directional motion. But if we draw, all right, let's talk about this question. Suppose you went 1 kilometer here, then 2 kilometer, then 3 kilometer in this side. So this is total distance 1 plus 2 plus 1, 4 kilometer. Okay, 4 kilometer is this total distance covered. This is a two-dimensional motion. Okay, total displacement will be this line. From this starting point we draw this line. So total displacement, we figure out how this change in y plus change in x. So displacement of the object, actually change in y is 2 km, change in x is 2 km. So displacement vector is 2i plus 2j. Okay, magnitude of the displacement root under 2 square plus 2 square, 2 root 2 km. All right. And if you have to find out velocity will be 2 root 2 into kilometer. If you change it into meter per second, 2 root 2 into 1000 by 5 minutes, total time 5 minutes is 6